Hi guys, welcome back. In my last video, we have talked about how to download a JSON data from the web service and save it to core data in iOS. In this video, I'm going to talk about how you can download a JSON data from web service and save it to a room database in Android using Kotlin. So that's what we are going to talk right now. As always, like I have created the app already. I will be walking you guys through the core components and how I have architectured the app. Let's start. In this project I'm using Android Studio 3.2 using Kotlin. So step one, let's go through the manifest file. Nothing major in the manifest file. Only one thing you need to do is you need to add the internet permission for the internet, and in your build.gradle, apart from the standard stuff, you need to add the recycler view, then retrofit to download data from the web service, then the JSON library for retrofit, and the room room db, and I am using anco library for async operations. So that's all with the third-party libraries that you need to set up. In this video we will be using this particular API, which is like Rally Coding Heroku app music albums. This is a very small API. It gives you a list of 5 albums, metadata of 5 albums by Taylor Swift. It has a property of title, artist, URL, image, and thumbnail image. So this is the web service that we'll be using for this project. Yeah, first of all, we'll be creating the response data model. So in Kotlin we'll be creating it as a data class. So data class music albums, and this will be the properties: the title, artist, URL, image, and thumbnail image. That's it. Your model class is ready now. Okay, the next step is to create our web service component. In this app I am using retrofit library to download the data from the web service. Here I have created an API interface which has a get method which takes in a path. Right now it is API slash music albums, and a function which returns an array of music albums. And I have an API service factory which will create the necessary retrofit component here, and it will add the converter factory, which is the JSON converter factory. And I have a helper here called constants, which has the base URL, and the path gets appended from the necessary function. You can have post annotation here, like right now I have only the get feature. So once using the API service factory, you can create a retrofit component and then make the call to the web service. So, and I have another component called result type. So this is just something similar to how we use in Swift, like where in which you can easily get the success or error data from the response as a enum. So you can easily use switch case to differentiate your error or success scenarios. So here I have 3 cases: success, error, and whether the data is in the loading state. So according to this you can show a loading indicator or error or success alerts, like that. So this is pretty helpful in asynchronous scenarios. We have the response data model and the web service component ready. Next thing is our database. So here we'll be using the room database, which is part of the Android architecture component. Let's go and see what is there in the room database. A room database consists of three major components, as you can see here. One is the database, which is the actual database. It should be an abstract class that extends the room database. Then you have the entity. So entity is the table within the database, and the DAO, which is the data access object. These three components, these three are the main components of the room database. The application uses data access objects to get the entities from the database and save any changes back to the database, etc. So it's like your persistence coordinator kind of thing if you try to compare to the iOS. Now adding room DB to your project, so that we have already seen. So you need to define the version number of the room database and have these two lines like implementation and annotation processor. In the case of Kotlin, we should use capped keyword, and we should apply the capped plugin so that it properly gets updated. Like if you go here, you can see here I have used capped and I have used apply plugin. Make sure these two steps are done. Like if this line is not there, you will get error. So make sure these two things are in place. So that is the main thing about room database. Your database component uses the DAO to fetch data from the entity. Let's see how it is created. First we need to have an album item, which is your entity. So this is how you define your entity, like your table, and these values are going to be the attributes or the column info. So in this case you have a table name called albums, and the album contains these number of columns like title, artist, URL, image, and thumbnail image. And I have created a ID as general integer as primary key, and I have set it as auto generate to true. So that means when you add new data, it will auto generate the unique identifier. So that's all about your entity. This is something similar to NS managed object. Next thing is your album data access object. So this is the main part where you will be writing all your something like your fetch requests. So here you can use the query annotation, and you can write the exact like your SQL queries. For example, if you want to fetch all the data, so you will be writing the query select star from the table name, the table name. Then you will be providing a method here which gets called. Then let's say for example you want to have a particular condition, like you want to fetch albums which is having a particular title. Then this is the way you should do. Like we will be passing the title value from the caller, and this title gets appended over here. So this is how the mapping works. So whatever parameter is in the function, you should provide the same parameter in the query also. Here I have another one. It's again like to fetch the album, where the artist name matches whatever is being input. And here I have done like, so here you can see that you get a list of values because there can be multiple items. Here I have put a limit 1, so as to ensure that I get only 1. Then you have another two annotations, which is insert and delete. So this is like you can insert albums as a bulk and you can delete a particular album item. So this is what our queries are, something like your fetch request. Okay, we are going to look at the album database, the actual DB. So you will be using the @database annotation and you will be mentioning the entities. So if you have multiple entities, you will be using you will be separating it using comma, and you will be providing the version number here. So right now I am telling the database that this one of the entity is going to be album item, table which contain album items. Then yeah, as we read earlier, it has to be an abstract class which derives from the room database. So I call it as album database. Then it will have a abstract function which is the album DAO, which is again type of album DAO. Then I am trying to create a singleton instance here using companion object, nothing but like you pass in a context, and using the context you will be creating a room instance, room database instance, using the database builder. And this is the name of the DB that we are going to give, albums underscore database. Like if an instance is it's the old stuff, like if an instance is null, create a new instance and send it back, else return the existing instance. So that's all. Now we have the data model for the web service. Then you have the API interface available to fetch data from the API, and then we have the database things also created. So all three components are now available. Next step is to have someone make use of this component. So as we discussed in iOS, also here also we are going to create a component called Datastore, which is like a helper to your UI or the main activity. The Datastore will act as a abstraction layer to your UI. So whoever wants data, the Datastore will supply. Let's go and see what is there in the Datastore. Datastore also has a singleton instance, like I'm using an object, companion object, and it has a function called get music album data, and I'm providing a response callback which will send an array of result type which accepts an array of music albums or error as the case it applies. Then I'm creating a using the API service factory, I'm creating a service instance, and from the service instance I'm just calling the get music data from the API interface and enqueuing it into the retrofit. And here I am handling the fail and on response callbacks. Let's say if you have a failure, then you will be passing in an error like unable to fetch data as an exception in the result type, and in your, if the response is successful, you will be sending the album information back, like array of music albums. So that's all the Datastore does. Let's go and see what is there in the user interface. Let's go to our layout file. We have two layouts here, like activity main and album cell layout. Like if you open activity main, you can see that it has a list view which I called as an album list view, which is constrained to the whole boundaries. Then I have an album cell layout, which is for each cell. So it has a main text and a subtitle text, main and detailed text. So these two, the layout is pretty simple. These two are the layouts which we have right now. Then I have a album data adapter. The album data adapter is pretty standard stuff when we talk about recycler view. You have an on create view holder. In the on create view holder, we are inflating the layout from the album cell layout and creating a new view holder. And in the view holder, you are assigning the data to the main text and the detailed text. Like in case if you want to have any click listeners, you can add the code here. And then number of items is taken here, and the item size, like it's pretty standard stuff, like your row count, section count, etc., and your table view cell. So similarly you have the view holder here. How this is populated, we'll be seeing in seeing later. Major component would be on bind view holder, where in which we will tell okay which item to be bound. So we have a function here like bind. So we will be sending in the album item, and which get assigned to the view holder, which is the album layout, album cell that we have. Then you have the on create view holder, which actually creates the view holder item by inflating the layout. And you have the get item count. This will be the number of rows kind of thing. The main activity. So in the main activity, I am initializing the database. So using our singleton instance, I just created a property which is an internal property, so that we can use here. So I'll be passing in the current application context so that it can be created. Then we are calling the retrieve albums function. So if you look at the retrieve albums, what it does is it makes use of the Datastore class and asking the Datastore, okay, please get me the album data. And you can see here, this is how the results get useful. So you get the result object. You first check whether the result is null or not. If it is not null, you use the when statement and you'll check the status. Okay, if the status is error, display the error. If the status is success, okay, get the data out of it from the result dot data value and process it. So here what happens is you will be getting the data and saving the data into the DB. So first, like, you call the web service, got the information, okay, you came to know that the web service call was successful, and you will be getting in the array of music albums, and you will be passing into another method called save with the data. Let's go and see what is there in the save with. So the save with function takes an array of music albums. Like, first of all, we need to convert the music albums into album item. Like, music albums is like a plain response model, and we need to convert it into the album item or the entity model, which is something similar to converting the response model to NS managed object in the case of iOS. This is just a debug method. In case if you want to see where the DB is being created, you can use this and print it out. So here I am looping through the item and then converting the music albums into an album item, and I'm inserting the items into the database. After inserting, I'm just trying to do a fetch, and the flow is like you are fetching the data from the web service, inserting it to the DB, and reading from the DB to show it to the UI. In the case of iOS, we had fetch results controller perform fetch to fetch the value and display to the UI. Here we have to do it ourselves, so we are doing the fetch all call here, and once we get the music albums, we are asking the UI to refresh. And here you can see I'm using do async, so all the database operation needs to be done in a different thread, not in the main thread. So here I am using unco library to do this. Do async is part of unco library, so it will be whatever you put within the closure will be done in a asynchronous thread. And if you want to post anything back into the UI thread, you can use activity UI thread. So here I'm just showing a toast. This long toast is also part of unco library, and then I'm calling this refresh UI with music albums. Okay, now let's see what is there in refresh UI. So this is where you bind the data with the adapter. So you are just getting an instance of the album list, and you are telling creating a layout manager and telling that it's a linear layout manager, adding the item decoration like the dividers to the table, then creating the album adapter. So here you will be passing your music albums as part of the initialization. This data, the album adapter will create all the view holders and rows for you, and then you will set the this current adapter to your list adapter. So that's it. This will load the UI. So that's all with this app. So what we have done here is we have designed the data model from the web service. Then we have created the API interface, how to access a particular data, how to make a call, etc. Then the result type. Then we have created the album item, which is your entity. Then album DAO, which is like your a collection of fetch requests. Then your album database, which is your actual DB. Then we have seen the Datastore, which acts as a helper to your UI. Then we have seen the layout. Then we have seen the main activity, a couple of methods which goes and fetch the data and reloads the view. Then we have seen the album adapter. So that's all with this. Now let's run and see how it works. Okay, you can see that the data is getting loaded. So as you can see, like I have run it multiple times, so I am not doing any special checks here. So each and every time when you run the app, the data gets freshly appended. Yeah, and you can write more logic to prevent that, but this is just a initial sample simple app which just shows how to download the data from web service as a JSON and then save it into a room DB. If you want to see where your database, the created database is being stored, like if you want to inspect the data, what you can do is go to the right hand side of the Android Studio, click on Device Explorer and click on Data. Again click on Data. This will show all the information or the apps present in your app. So find your package name, yeah, com.example.anupam JSON to. So open it, you can see databases. So select all the three. You can do a save as and copy into your desktop or something. You can use tools like DB browser for SQLite. Just drag and drop your DB and click on browse data. You should be able to see the information. You can copy these 3 files into the DB Explorer. Then if you go to browse data, you can access the data. You can see the structures. See, so that's how you view the. I hope it has helped you. I will be providing the link to the source code etc in the description. Yeah, please feel to ask any questions. Thanks for watching. Bye bye.